The next thing we need to talk about is what's called the Nth Term Test. So let's look and see what this Nth Term Test says. It says if we have a series, we're going to look at the terms. The terms have to keep getting smaller and smaller, but here's the big thing: if the series is going to converge. It doesn't say it will converge. It says that has to happen in order for it to possibly converge. It doesn't say if they're getting smaller, it will converge. That's not what it says. A little confusing. What it does say, it says if the terms are not getting smaller, it means it does diverge. So if the limit of the terms equals 0, so if the terms are getting smaller and smaller and smaller, this tells us absolutely nothing about convergence and divergence. Nothing. However, if the terms are not converging to 0, it tells us the series diverges. And that's called the Nth Term Test, or the test for divergence. Wow. Let's try to clear this up by comparing a sequence to a series, because that's what most students get confused about. Okay, so this is a sequence. It's just a list. This is a series because we have the sum of the associated sequence. So if I take the limit as n approaches infinity of n plus 1 over 2n plus 1, that equals to 1/2. And so we could say the sequence converges to 1/2. The sequence converges. But now let's look at the series. Okay, because the limit as n approaches infinity of a sub n, which is that. Let me write that again. The limit as n approaches infinity of n plus 1 over 2n plus 1, which is what we just did over here. Since that equals to 1/2, which is not equal to 0, then we can say the series diverges. And that's because of the Nth Term Test. If the sequence does not have a limit of 0, then the series diverges. Be very, very careful. Let's just look at some more examples. So we're going to see if it converges or diverges. If it converges, find its sum. And we really need to make sure we state our reasons for our conclusions. Okay, so we have a couple of different ways to approach number 8. One possible approach is to say this is geometric. This is a geometric series. We have a number raised to a power. That number is the square root of 2, which is greater than 1, so it diverges. Option number 2 is to use the Nth Term Test. The limit as n approaches infinity of the square root of 2 to n does not equal to 0, and so we could say it diverges because of the Nth Term Test. So somewhere along the line, I've stated my reasons. I'm saying it's geometric, this is why it diverges, or I use the Nth Term Test. Don't have to do both, but you have to pick one and again give your reasons. Let's look at number 9. What is this? Is it telescoping? Is it geometric? What is it? Well, you could write out some terms. When n is 1, you're going to get 1. When n is 2, you're going to get -2, +3, -4, +5, and so forth. What's happening? Well, the limit as n approaches infinity of just the sequence, so just this part, what's that limit? As n approaches infinity, are we getting closer and closer to 0? No. So we can say the series diverges, and again, I've used the Nth Term Test. So make sure you state those reasons. So looking at example number 10, we've seen this before, the cosine of n pi. So when n is 1, we have the cosine of pi, which is negative 1. Then we'd have the cosine of 2 pi, which is positive 1. 3 pi, negative 1. So this just goes from negative 1 to positive 1. So our first term would be negative 1/5 to the first power. Then we'd have positive 1/5 to the second power, and so forth. So what kind of series is this? It's geometric. So I'm going to write that down. And if it's geometric, I should be able to determine what r equals to. What am I multiplying by? Negative 1/5. And I know since negative 1/5, since the absolute value of negative 1/5 is less than 1, I know it converges. And it says if it converges, to find its sum. So the sum is a over 1 minus r. So let's see, a is negative 1/5, and r is also negative 1/5. So my sum is negative 1/6. So it's geometric. I've shown why. It converges, and there's my sum. Now look at number 11. That looks scary. So just like integrals, you can separate because of pluses. You can do the same thing with sigmas. Okay, so you have a series. You could say 2 to the n over 4 to the n plus 3 to the n over 4 to the n. And then you might want to reduce this fraction and write this as 1/2 all to the n power. And I'm going to write this as 3/4 to the n power. What kind of series are those? Are they both the same? Yes, they are. These are both geometric. Hopefully you can see the pattern. You have some number being raised to a pattern. That's a really big clue that it's geometric. But always convince yourself if you're not totally sure. Here, r is 1/2, which is less than 1, so I know I can find the sum. Here, r is 3/4, which is less than 1, so I can find the sum. So I could add these together and find the total sum. Okay, so if this is the first one here, what's a? If I plug in 1, a is 1/2, r is 1/2. And for the second one, if I plug in 1, I get 3/4, and I know r is 3/4. So doing the arithmetic here, I'm going to have this is equal to 1, and this is equal to 3. So my total sum is 4. So these converge because it's geometric, because my r values are both less than 1.